The Sansui BA-5000 was quite a project, but what a wonderful amplifier. This is the one amplifier I will never get rid of, and it will drive any pair of speakers down to 2 ohms at its rated 300 watts per channel. If you haven't already, please subscribe. The repair and restoration of this BA-5000 took me a lot of hours. How many hours? I really don't know. This unit had several issues. It had been put out to pasture a long time ago. If there's any amplifier that's worth the time, it is an amplifier like this one to get it back running again. She'll never be cosmetically perfect, and frankly, I could care less. It operates great. I have a lot of equipment that is not cosmetically perfect, believe me. Some a lot worse than this one, and I enjoy them just as much as if they just come fresh out of the box from the factory. So that kind of stuff doesn't bother me. I'd like to talk to you a little bit about the Sansui BA-5000. It was rated at 300 watts per channel into 2 ohms, 4 ohms, or 8 ohms. It has 3 separate speaker taps at the back, one for 2, one for 4, and one for 8 ohm speakers. This was the only Sansui amplifier ever made with output transformers. Transformers sit between the output of the amplifier and your speakers, and it ensures an even load that remains constant no matter what your speaker's impedance is. So there may be a speaker that this amplifier cannot drive, but there aren't many. It doesn't matter how difficult of a load that your speakers would present to this amplifier, it can probably handle it. I obtained this BA-5000 at Christmas of 2018. It was a Christmas gift. I have a high-end dealer here in town, and from time to time he'll get people bringing in equipment to sell to him, and I stop in from time to time just to see if he's got anything, and he had this BA-5000. Well, I talked to him, and I couldn't make a deal with him, but I came home and I told my other half about it. Unbeknownst to me, she went down there and made a deal with him and brought it home. That's how I obtained my BA-5000. Whenever I obtain a new piece of audio equipment, the first thing I do is go to HiFiEngine.com and download all of the documents they may have on it. Sometimes they have the owner's manual, sometimes they have the service manual, sometimes they have brochures, sometimes they have all the above. So whatever they have in documentation, that's my first stop whenever I obtain any piece of vintage audio equipment. Many times the service manual will give you valuable information that you just won't have without it. The service manual is what you're really looking for if you're restoring or repairing any type of vintage audio equipment. So after getting the documentation that I would need to work on this BA-5000, I put it up on the test bench and just took a look at it. I took the covers off. I just looked at it with my eyes, and that's the first thing you guys should always do with any piece of equipment you acquire, because a lot of times you can see something without plugging it in. Instead of plugging it in the wall, let's try it kind of attitude, and you end up blowing it up. In this one's case, it had so many different issues that I could see that I knew there was no way I was going to be able to power up this unit for quite a while until I figured out what was going on with it and why it was in the condition it was in. I love going back and getting the old brochures on the equipment and reading it. I don't understand most of what they're even talking about in these brochures, but this is what I did when I was a teenager. I'd go to the local store and look at the equipment, and they always had brochures for you to take home. And I'd pick up something. Sansui was always one of my favorites, so I always had a bunch of Sansui brochures, and I'd bring them home and look them over. And as I said, they they were one of my favorites, but they're trying to talk you into buying a Sansui and not another brand. So they talk about how wonderful they are, and frankly, they are wonderful. I bought several different Sansui pieces of equipment in my younger days. I probably bought more Sansui than anything else, actually, and I still have some pieces today that I purchased when I was a teenager. I don't have them all. I wish I did now. Back then, I would just get a new piece of equipment, and I remember selling a few of the pieces to friends. I would go buy something new, and they'd buy my old stuff, and it just kind of went on like that. But reading about this BA-5000, I just enjoy looking at the brochures. I look at this picture of the heatsink with the power transistors mounted in it and how pristine it looks. And then I think about mine and the way it looked. It had such a mixture of power transistors, and it looked like it had been in a barn for 20 years. What a mess it was, but it cleaned up and it looks just like that one does now. So that's interesting seeing that picture. But it's an amazing, amazing sounding amplifier. A lot of times I don't talk about the sound quality of the equipment. I've got a lot of it, and I've compared a lot of pieces with each other. But as I mentioned early on in the video, this is the one amplifier I will not sell. It is just perfect for me. I believe it is the most balanced amplifier I have. Obviously, it's got a ton of power. Obviously, it can drive any speaker that was ever made, but that's not the main thing. It really sounds great no matter if you're driving it hard or if you're just sitting back just with a cold beverage and just casually listening to it. It never is a disappointment. It's a tremendous sounding amplifier as well as being physically impressive. So how did I get this BA-5000 from being basically just a heap of junk to something that now should operate for the next several decades? It'll be around long after I'm gone. I'm very confident of that. First of all, I'm not a professional. I'm not one of these people that you see me pulling out the schematic and explaining to you how a transistor or an integrated circuit or how any circuit works. So what I do bring, though, is some common sense and a little bit of experience from working on this stuff. And I knew that this amplifier, from experience, from blowing up other amplifiers, from basically destroying other pieces of equipment. Fortunately, that hasn't happened too many times, but it's happened. I didn't know enough to be careful. So I'm one of those people that, you ever hear the term, I know just enough to be dangerous. And I went through that phase. You know, I thought I knew what I was doing and I would take chances, and just because I shouldn't say I would take chances, I just didn't know what I was doing at all. And so I made some errors, and I've hopefully, as I said, have corrected most of those errors. So by the time I got this amplifier, I had some experience and I knew I had to be very careful. I feel there's probably a lot of people out there like me that just need a little bit of guidance to fix their equipment. There are not many people working on this stuff anymore, and it's going to be very soon that most people are going to be really on their own with this stuff, and you're almost there now, right? It's very difficult to find anybody to work on your piece of equipment, so you're on your own in a lot of cases. And as I said, a lot of this is just having some common sense. First of all, you can get injured or, in a rare case, killed because you've got something plugged into your mains. So if you don't understand that, first of all, you don't even try to work on it. Realize, like I did, that there were a lot of people working on the stuff at one time. So that tells you one thing, what? It's not something you need to be an Einstein to work on. It doesn't mean that some of it's not difficult to fix. It just means that it truly is possible for somebody with average intelligence and some patience to learn, like most functions. If you believe you're doing something that nobody else in the world can do, then go at it. But I just think that most things in life, anybody can learn it with some experience and some patience, and this is one of them. I'm going to continue on with the Sansui BA-5000 repair and restoration, but I want to go over a few more items just about you guys being able to troubleshoot your own equipment and what you may need. Of course, you need that service manual. I always talk about that. I won't go on about that. You need some sort of a spray to clean those pots and those controls. And I use Deoxit D5 and F5. Experience is the #1 thing that you'll find that you need to work on vintage audio equipment. I don't recommend working on your precious receiver that you went to college with, or your dad's receiver that was handed down to you that you want to get going. You don't want to work on that first if you've never worked on this stuff. You want to go get a piece of junk, whether it's at your flea market, a yard sale, Craigslist. Just go get anything and get used to being able to open it up and disassemble it. That's part of the trick too, is being able to look at these things and how does this come apart. Now, if you downloaded the service manual, usually they'll have some mechanical layouts and even sometimes give you instructions on how to disassemble. But experience. So if you've never attempted this, don't do it with your precious equipment. Go get a piece of junk and let it be the guinea pig. And once you get a little bit more comfortable, maybe you can work up to working on your piece of equipment. One thing that you can do is just take a look at your piece of equipment. I had a Sony, and still do have the same Sony, TAF6B. I didn't need a meter, I didn't need a scope, I didn't need any piece of equipment other than my eyes. What had happened is one of those electrolytic capacitors that I harp on blew off a piece of artwork. Took out a transistor with it, and I can't remember what else, but had to repair the artwork with a wire, had to replace the transistor, repaired the 40-year-old capacitor that should have been gone 20 years ago, and guess what? It powered up. So here, that's just an example of how you could repair something with no test equipment. You can use a digital multimeter to test the DC offset at the speaker outputs. You don't even have to remove the cover of a receiver or amplifier, and it just kind of gives you a general health. It's certainly not the end all, but it gives you something. It's simple, it's easy, and it's something that you should do. Closer to zero, the better. You get up in the 100 millivolt range, that's something you're probably going to start to hear. It's just a real quick and easy test that you can do in 5 minutes. So that's something you can do with a multimeter. Now I'll talk about how you can use an oscilloscope and a signal generator to help you troubleshoot a problem with your vintage audio equipment, even if you cannot read a schematic well. The great thing about stereo equipment is what? You've got 2 channels, so isn't that nice? And if you've got trouble with one channel and the other channel works, well, you've got a helper right there with you, and that's the other channel. Even though the schematics, and hopefully you've downloaded the schematic for your piece of equipment, most of the time they do a pretty good job about giving you voltages at certain spots, signals at pictures of signals at certain spots, so it helps you troubleshoot it. But really, when you're inexperienced, your best helper is that other channel. So if you've got 24 volts, let's say at this pin, and you're not sure if that's right or not, if you go over to the other channel and it's 24 volts, then you feel pretty good, that's not the problem, and you keep moving on. But really, for this, you do need an oscilloscope. And you do need a signal generator, because if you just got music going, you're not going to be able to tell what's going on. You need a signal generator that can produce one frequency consistently so you can watch it go through. As I said, the great thing is with 2 channels, so let's say you've got a receiver. I spoke of a preamplifier and amplifier, but let's say you've got a receiver. First of all, and you think you've lost one channel, so let's say your left channel is bad. First of all, you've got to figure out, is it all the inputs? So, you know, you hit FM, yeah, my left channel's still out. I hit phono, still my left channel's out. Aux, still my left channel's out. Channel's out in all of them, so it's either in your amplifier section or preamp. When you're actually inside the unit and troubleshooting an issue, you've got to be very careful of not shorting leads together. You also got to be careful for your own safety, as I mentioned before. If you're new at this, you're going to make mistakes. Even if you're not new at it, you're going to make mistakes. And so this is why I said at the beginning, if you are new, get that piece of vintage equipment that you don't care about. Maybe you've got something in your closet. As I said before, purchase one for a few bucks and play with that one, because inevitably you're going to make mistakes. We all do. So once again, just be very careful in there. You don't hurt yourself or you don't damage the equipment. So now you can take those two leads from the scope. We know we've got a problem on one channel, and you can get one probe on one channel, the other probe on the other channel, and compare them. It's great. You've got the best helper ever. You know, there's nobody who knows this stuff better than the other channel, right? So you can compare signals. And if you see a difference, even if you don't understand what you're seeing, you know it's different. And then you can work your way back to where they're the same. You'll be able to narrow down a problem instead of, when you first open these pieces of equipment up, if you haven't before, it's going to be daunting. You're just going to look at it and go, you know, where do I even start? But just take it a block at a time and narrow it down, and you'll find that with experience, as I mentioned before, it gets easier and easier. And that's the whole key. I think most people that work on this stuff, they'll tell you that you'll have certain projects that are very, very difficult, but over time, you gain more experience and it gets easier. Just like anything, I'm sure you guys out there, you all do something very well, and you might be able to even teach somebody like me what you do. I wouldn't be as good as you at first, but I'd have to keep practicing, and that's what you got to do with this. I've tried to give you a little bit of information about how, even if you're not an expert, that you can kind of get in there and gain a little bit of experience, and maybe down the road you will be an expert. There's a few tips on how to troubleshoot your vintage audio equipment. The first tip is just your eyes. Take a look at it and see what you can see. Sometimes you can find something. The second one involves a multimeter. A lot of folks have those, some don't, but you can get one that's halfway decent. That one that I showed in the video, it's about $30, $35, fairly inexpensive, and you can really do a lot of troubleshooting with that. And then the last two, which involve the signal generator and an oscilloscope, those are a little bit more involved, and a lot of people don't have those. There are signal generator apps that you can use on your phone, so that's one thing that you can do. And the oscilloscope really doesn't have to be anything special. Almost any old scope over the last 40-50 years is going to work, so you don't have to go out and spend several $1,000s on some state-of-the-art oscilloscope. Any of the old ones work great with vintage audio equipment. So those are just some tips. Hopefully they help you out. Keep your equipment going as I've kept mine going. Make sure you click that show more button that's at the bottom of my videos and just scroll down, because I've got links to all of my troubleshooting videos here on YouTube. Every one of them. So whether it's an individual piece of equipment, whether it's general troubleshooting tips, it's all there. So it's a great resource for you to keep your equipment going also. I hope the preceding few minutes will help you guys keep your equipment running also. But it was also the techniques I used to get this Sansui BA-5000 back to life. As I indicated earlier, I'm not a professional. This is a hobby for me. So I had to learn how to do this on my own. Many of the techniques you just saw is what I used in this BA-5000. So now I'm going to show you how I approached this BA-5000 and how I got it back up and running. and how now it's one of the most important pieces in my collection. This amplifier weighs about 100 pounds, so you get a pretty good workout just trying to get it up on the test bench and moving it around. This BA-5000's pretty scratched up, kind of beat up. The top covers are all there. Some of the screws are missing. See, there's a lot of dirt inside this. This was stored somewhere for a long time, but that's not unusual for something that's 45 years old. A lot of the vintage audio equipment is a mess. I found that when I took off the side panels, I could see that the bias transistor that's normally attached to the power transistor heatsink is loose, and it was wrapped in electrical tape. So that didn't give me a great feeling right off the bat, but that's why you should take a look before just plugging it in the wall. And this bias transistor, in this unknown condition, it could cause major damage in short order. The other channel, I took the side cover off the other side, and guess what? The bias transistor's wrapped in electrical tape over there and just kind of hanging loose, so got the same problem on the other side. That's not a good thing. Very important to look at this equipment before you apply power to it. I don't know what would have happened if I just plugged it in, and but probably nothing good. So I took the bottom cover off also. I see another Christmas present just looking with my eyes. I see something else that's wrapped in electrical tape. I take a look, and it's a resistor, and I found out from the schematic it's part of the fan circuit, but I've got a lot more important issues than the fan circuit, so I'll figure out what this is all about later on. Looking from the bottom again, I can see the regulated power supply assembly, and I was happy to see it looked like all the original tie wraps were in it when this amp was manufactured in Japan in the middle 70s, 1970s. So I don't think anybody's touched this, which is, the first thing I've seen that hasn't been touched, so it made me feel pretty good. It looks like the original filter capacitors are still there, original rectifiers. I did see when I was looking on the bottom that the power switch apparently had failed, or something had happened with that, and it was bypassed at some point, so I seen this electrical cap, that you tie wires together with, staring me in the face, and I did see there was no power switch in the front, so that's what that was about. And in the back, we've got a speaker post that's broken off. Also at the back, I could see a lot of dirt, dust, grime on the fan. And after removing the fan from the heatsink assembly, I got my first look at the grime that's clinging to the output transistors. Pretty good mess, no doubt about it, but I've seen them like this before, believe it or not, but it's going to take a lot of cleaning to get this, just cleaning's going to take several hours. I did notice, just looking at the output transistors, that many of them are not originals that came with the unit when it left the Sansui factory. There seems to be just a mix of transistors in here. Sankins were the original ones, and I see some of them, and then I just see, I don't know who the manufacturer is of some of them. I see date codes on a couple that have I believe 1985, so I know these weren't original from Japan, but again, this is something down the road that I'll have to look at. I'm going to have to take this thing apart, and I've removed the heatsink output transistor assembly. And I'll clean up the chassis, while that's out. It's easy to get at that. I live in Florida, so in the winter months I'll sometimes take some work outside. This heatsink output transistor assembly is the perfect thing to take outside to clean up. It's a mess. I've taken it out to the driveway, and I'll blow all that crap out here. Then, a lot of times I'll, and usually I do this in the winter months. If Florida, I wouldn't be sitting out here in the summer, right? Very hot, very humid, but in the winter, it's gorgeous out, so I don't pass up on working outside if I can, and this was a project that I could. But sometimes, it gets kind of warm out there in the driveway, so I'll move to another area, get under some shade. But again, work outside, it's It's just a lot nicer than being cooped up inside a room on your test bench sometimes. So I've started to remove the power transistors from this assembly. You know, I just got to take it apart to clean it up. I'll put in new insulators, and I just got to see what I got here as far as the transistors go. And I tested each transistor just to see what I had. I have an Atlas DCA Pro that will test out the transistors and give me their gains and just give me a general idea of what they are. Some of the transistors tested very poorly, and others look like they were hit with a small hammer. You know, once again, this unit's about 45 years old, and who knows what's happened to it over the decades. I'm going to try to keep the ones I can. Probably going to keep the Sanken drivers, and I'll have to replace the other outputs. I just lined them all up, and it's just a mix match of who knows what's there. So I've got I got all the power transistors out of the heat sink, and I'll clean that all up. Once I reassemble all this, I'll put new thermal compound and new insulators. Again, the F2516 and F2517, the connector boards that this all hooks to, it's a mess also, and I could see that some of the emitter resistors were replaced at some point. So, I mean, this is going to be a big job, so I disassembled all of that. I took out a bunch of screws and just took the whole assembly out, and so I could just take a good look at it. Just, again, see what I've got, or the best that I can. Check, make sure the emitter resistors are good, make sure where these things have been changed out, the soldering looks good, and while this is all apart, this is the time to do it, because hopefully nobody has to do this for another 45 years. Plenty of dirt and grime just everywhere, and some of the stuff you just clean up, like on the heat sink. You know, it's easy enough to clean it up. It just takes you some time. And when you do that, heat sinks don't look much different than they did when they were new. So you get that all cleaned up, and then you got to flip over the heat sink, and this is where you clean off the old thermal compound. And once you get it cleaned up, it looks brand new again. I'm using, for replacements, I'm going to use the Sanken drivers, but to match the outputs, there was one channel still remaining of the original Sankens. I'm going to put those aside, and I'm going to change both the left and right channels output transistors with on-semi MJ1193s and MJ1194s. These are great output transistors. They'll work fine in something like the Sansui BA-5000. Thermal compound and then insulators. I did that. I applied the new thermal compound, the new insulators, and got the transistors, the new transistors, along with the Sankens that I'm saving, the original Sankens that I'm saving, back into the heat sink. Sometimes, you know, again, just talking about dirt, if you've got something, you know, that you can just take to the garage sink, that's the way to do it. And some of the parts, that's what I did. Brought them on out and cleaned them with some dish soap and warm water. It looked like new. So now I'm going to keep on moving. I'm going to work on the 2518 driver board. This is the one with the hanging transistors. This one comes out quite easy. And then really this whole unit, there's nothing super difficult about getting it apart, which is helpful. Now I can go ahead and take a look what's under that tape that I saw in the beginning. So this is the transistor that was hanging out the one side. First of all, you see these red wires. Those aren't original. I think later on you'll see the other driver board had its original wiring. The bias transistor also, it's a 2N2222. That's not original either. At some point this was worked on, and once again, you just be guessing about what the problem was and what was being done. While I'm there, of course, you know, these are 45-year-old electrolytic capacitors that are on this board. I'm going to go ahead and change those out while I'm here, you know, because I'm going to do that anyway. You'll notice, like some folks, you may see this glue on old capacitors. They just use that during assembly to hold them in place when they flow soldered these boards. So any 45-year-old capacitor, electrolytic capacitor, should be replaced. But if you see this brown stuff at the bottom of many of them, it's not that they're leaking, it's just that it's the old glue that they used in the assembly process. But that old glue, you should really get most of that off. Some of it has been shown to cause issues with eating the artwork or eating other components near it after decades. So, and this stuff will usually come off fairly easily. You know, an X-Acto knife works good, a small screwdriver, sometimes fingernail, just kind of pick at it and it'll come off. It's going to take you some time because there's a bunch of these and you're going to have to clean it off. But again, after 45 years, that's what you should be doing. I'm going to replace the transistors on the driver boards with modern equivalents. Are these bad? I don't know because I haven't even powered this up yet. But while I'm in there, many of these transistors are quite inexpensive. And after 45 years, it's probably the wise thing to do because you don't want to get back in here again. There's plenty to clean up on the back of the boards. I mean, while you're here, you can look at the solder connections, and if not anything else, clean the dirt off of there too. In certain areas of any vintage piece of equipment, including this one, some spots, some circuits where you should use audio grade replacement capacitors. They were audio grade back in the middle 70s, and the same ones should be replaced today, the equivalents anyway. I'll clean up the connector pins. Here's another thing that after 45 years, you've got these pins. Why not clean them up also? You're in here, you should do that. The other driver board, the other one with the hanging bias transistor with tape on it. But again, taking just an eyeball, you know, I'll go ahead, like in this board's case, I saw a suspect resistor. It just shows heat damage. Did it measure fine? Yeah, it did, but something happened there. So I replaced it just to replace it. I mean, why leave a 2-cent resistor that's 45 years old that has some kind of heat damage to it? Why you leave that in there? So I changed that out. The filter capacitors checked out all right, and for now I'm leaving them because I've just got so many other issues here that the filter capacitors are, again, one of the least of my concerns, and I do believe those are still good. They looked, you know, there was no leaking. They measured well, so they're going to stay in there for now. I'm going to rebuild the regulated power supply, though. I'm going to certainly do that. It's always a great idea to, well, first of all, have the service manual. And the service manual for this is available at hifiengine.com, but also take pictures. You know, in today's digital world, take those pictures, because you pull these cables off, you don't want to be putting something back incorrectly. Certainly not on the power supply, nowhere else either. But take pictures this way. If there's some confusion when you're putting things back together, you can do it. Now, in this board's case, you can see, you know, it comes right out. I'm holding it in my hand. Well, that makes it heck of a lot easier to work on, you know, with the head modular connectors in this unit. And some units from this era, you know, they were wired point to point. It's much more difficult to work on them. But this one comes right out in your hand. Bring it down here on the test bench, and it's easy to inspect the artwork side. And it's also easy to replace components. Here on the power supply, I'll be using a lot of PW series capacitors. They're high temperature rated. They have a great reputation. And, you know, just for an example, you always want to use the same value capacitor and at least the same voltage, if not a little more. Here, you know, I've got 100 microfarads and 80 volt, and they're going to be replaced with 100. Just a little extra. Size of them are quite a bit different. Here's a 16 volt original capacitor out of the BA-5000, and here's its replacement, you know, which I'm going to replace it with a 25 volt, but it's half the size. I'm going to replace the regulator transistors on the power supply also. They're still working. They might work another 45,
But geez, again, these OMs, I'm going to replace them with onsemi MJE 15032G transistors. Once again, these are transistors that have a great reputation in today's world, and there's a good bet they'll last 45 years also. Once again, you're in here. Do you want to come back? Probably not. So I've got the F2521 power supply rebuilt, new transistors, new electrolytic capacitors. Rebuilding the power supply in any vintage audio equipment is probably the most important step to making a unit reliable. If something goes wrong on the power supply, whether it's on this unit or any other, anything from the unit doesn't work to the unit blows up. The power supply usually are under quite a bit of stress in these units. That's just a must, no matter what. You got a 45-year-old piece of vintage stereo equipment, you need to rebuild the power supply. So I've reinstalled it back into the chassis. Cables, I'll hook those back up. Once again, you know, a lot of times these things are keyed. You can't make a mistake. Some, though, on this unit are individual wires. So you don't want to, you know, mix those up. If you've taken pictures and there's some confusion, you can go back and look at that. I think I'm going to move on and get the faceplate cleaned up, and to clean that up and to get the rest of the assemblies, that means remove it. So I'm going to remove the faceplate. The dirt and the grime, again, gets everywhere. It's even in the meter assemblies, and they're going to need to be cleaned. But again, not a surprise after 45 years. I'm going to remove the F2520 buffer amplifier board for inspection, and also, again, to replace those 45-year-old components. The buffer amplifier, that's attached to the front of the BA-5000. It comes out fairly easily once you've removed the faceplate and the cables and the screws. Now take a look, take some pictures, lay the screws out in a way that makes sense to you. Don't get too far ahead, and it's not too hard to get out of there. Once it's out of the chassis, I'm able to inspect it much easier, get to those old 45-year-old components. And what I noticed, if you see in the picture, there's holes drilled into the pots that someone previous had been, again, working on this. This is 45 years old, not a surprise. And in this unit, that's not unusual because those are sealed. You take them apart, they may fall apart. So people drill them out, and then you can spray your deoxit right up in there. So when I saw that, I thought, well, that's what you got to do, to really get those cleaned up. Anyway, I sprayed a little more deoxit in there myself. Cleaned them again. You want to always, again, you've got this out, inspect the artwork side. If nothing else, the back of the board needs to be cleaned up, and you may be able to see something. I didn't see anything wrong with the back side, so I just cleaned it up. From what I can tell, a buffer amplifier had never been out. It had all the original components in it. This is not a short restoration. This is going to take you a long time to do it. But I think a Sansui BA-5000 is certainly worth it. And so again, electrolytic capacitors will be replaced, and the board cleaned up. And a lot of the modern capacitors are a little bit smaller, but you had a 16 volt in there, replaced it with a 25. If you had an 80, replace it with a 100. Just gives you a little bit more play there. Of course, the manufacturer, they were making thousands of components, so saving a few bucks per unit made a difference. The original capacitor shown here, heat damage to it to the side, and this was very near a power resistor. It survived. It lasted for 45 years, and do you want to leave that in there? I don't think so. So, of course, again, an electrolytic capacitor, even if it wasn't near a power resistor, you're going to replace it. But you can tell that this guy here had a rough life. Most of the electrolytics that I replace with are rated at 105 degrees centigrade. The ones that came out of it were 85 degrees centigrade. 105 degrees centigrade is 221 degrees Fahrenheit. These things get hot. You better hope it doesn't get to 221 though, but it's nice to have that little bit of play in there. Transistors the same way. Some of these older transistors are starting to get noisy. A lot of the little signal transistors I'll replace with modern low noise equivalents, and also again, get those connector pins cleaned up. This is your opportunity. I'm going to take out now the F2515 meter assembly. The meter assembly also has some electrolytic capacitors and transistors and diodes that need to be replaced. And I mentioned diodes on this board. And this board, by the way, is attached to the back of the meters. Comes right off, a couple screws, and you can bring it to your test bench. These little green and black, you see kind of like right at the front of the board, I'm holding it. Those little diodes have a history of failing. Many BA-5000s have flaky meter issues, and this is a leading cause why. They just, after 45 years, they've gained a reputation to fail quite often. So a lot of times you don't change diodes out, but these you do. In this diode's case, for the replacement, I combined two modern diodes to make an equivalent diode. I replaced those. Once again, check the artwork side of the F2515 meter assembly for any issues. Didn't see anything, but it's always good to take a look. Clean the pins. I use deoxit spray in a lot of places. Clean out, switches and the pots, but the liquid deoxit D100 works great. Just a Q-tip, and you can clean those pins right up just like new. I'm going to clean up, or I did clean up, the back of the meter assemblies. This is where those little boards attach back, but again, while it's off, clean that up best you can. No better time to clean the front than while you're holding the meter assembly in your hand. You can see quite a bit of dirt and dust on there, but this makes it a bit easier here holding on to it. Again, a lot of cleaning in here, a lot of cleaning, about 45 years of grime to take off. It's looking better. But there's a lot to do yet. I've gotten, a lot of the unit cleaned up. I've gotten a lot of the components changed out. And then I'm going to reinstall now the upgraded meter assemblies back in. I'm going to get that back together. Again, don't get too far ahead of yourself and have all this stuff sitting all around and not knowing where it goes. So I got that back together. And then I reinstalled the buffer assembly, that other piece that I took out. With the drilled out pots, I got that back in. So that area has been all upgraded and done. Now it's interesting, right? For all this work I've done, I've not applied power to this unit at all yet. And this isn't normally probably the way I proceed with a unit, but in this one's case, I thought this was the way to go. There were just too many issues, especially when you see the bias transistors wrapped in tape and all the other issues. It was better, go ahead, this was going to have to be disassembled anyway, go ahead and do some of this other work first before I even applied power to it. At this point, I've rebuilt the power supply, the buffer amplifier, the meter amplifier, and the driver assemblies. And I'm going to see if I can check those first. So the power, the output, the heat sink and the output assembly is not even attached right now. I just want to see if I can get this powered up without that assembly and put a signal through it. So the first thing I'm going to do when I power this up, I'm not gonna power it up off the full line voltage. I'm going to use a variac, but in addition to a variac, I'm also using a dim bulb tester with the variac. I'm being extremely cautious here, trying to prevent any damage that may occur. So I'll use meters and I'll monitor the voltage and current, and I'm going to try to prevent any damage if there's an issue. Hopefully I can see an excessive current draw. Hopefully my dim bulb tester takes the current and then doesn't cause and I don't have an issue. But anyway, out of an abundance of caution, this is what I'm going to do. So I found out, I powered it up. The first thing you want to check is the power supply voltages. Are those correct? You've got to have your power supply working before anything else is. As I said, all these preliminary tests were done without the power amplifier assembly installed. I ran, I had a signal generator and I ran 1,000 hertz sine wave into the ICA, RCA input jacks. I then I monitored the output at the driver assembly. The signal out of the driver assembly looked good on the oscilloscope, and I could adjust the gain controls, and those worked appropriately, verifying that the voltages look good and that I'm able to pass a signal from the RCA inputs out through the driver assembly. I'll move on now. So I feel kind of good about the work I've done up to this point, that I can get a signal in and get it out the driver assembly. I did notice, just powering it up, that one of the 6 fuse type lamps was burned out. The original lamp had a blue gel cap molded into the lamp. My replacement is just a clear lamp. So what I did, I just cut the gel cap off with a X-Acto knife, and I put the blue cap over my original. That looks just like the original. So, if I had all 6 burned out, or 4 of 6, I might have done it a different way, but only needing one replacement, I went ahead, just like I say, took the gel cap off the original and put it on my replacement. It looks good. I cleaned up the lens assembly. The fuse lamps are, so they look strong and even on the power meters. I'm going to go to the F2519 power supply board. It's a small board. I'm going to replace the capacitors there, the electrolytics. Once again, look at the back of the board just because I'm here, right? Turn it over, see if I see anything. Again, I didn't. A new Omron soft start relay will be installed. I did that. The exact relay is still available. $10 or whatever it was. Certainly you're in there. Why wouldn't you do that? It plugs into a connector, which is nice. Some of them are soldered in. This was just in a connector, so that was pretty easy. Just pull it out and put the new one in. Behind there are 2 3.9 ohm power resistors whose job it is to take a surge, that power surge when you first turn it on for a second or two. And I took those out. Those checked out fine, and they're extremely durable, so back in they went. So I put with the surge resistors and the relay socket and the new relay installed. This area is all serviced, and it's time to move on. Well, I found something else. I was looking around. I found a resistor that sits between the output transformer and the 8 ohm speaker tap of the left channel. It goes without saying, this resistor got very hot. What happened? Who knows? I don't know. I do know that within this little area there was a power resistor, but attached to the power resistor there was a capacitor. The capacitor was shorted. The resistor measured good, but the heck with that. I don't know. I mean, about burnt the place down, so looks like anyway. So I replaced that. Now with a burnt resistor off the output transformer, and this is one thing that is unusual in this. This is the only Sansui amp that ever had audio output transformers. But anyway, gave me some concern that the output transformer wasn't going to work, maybe had a problem. So I applied 25 volts AC to the 2 ohm tap, and I just took some measurements. And the AC voltages measured at the 4 and the 8 ohm tap, they both increased like you'd expect them to. So it appeared the output transformer was working. So that made me feel good. Again, this was the only Sansui ever made with output transformers. Trying to find one on the used market would be almost impossible, but with these output transformers, this is why this thing weighs 100 pounds. It's got these, it's got the power transformer, which weighs a ton, and these 2 output transformers that are very heavy. So now, finally, I'm back to trying to figure out what happened, or what the bias transistor in the tape, what's going on there. This other one, before I'd showed the other one, 2222 transistor, this one has a 2SC984, and the wires are broken. Now, in any audio amplifier, you got to make sure the bias transistors, you got that figured out, or in just short order. I mean, you can turn this thing on, and then I'll burn up my new outputs along with the old Sankins in a second if you're not sure what's going on here. And as I said before, the other one's got a 2N222 transistor under the tape, so these are both critical issues that have to figure out a solution for. I experimented with a bunch of different ones. And I finally settled on a K, because, you know, the originals, you can't, you know, call Sansui and say, send me 2 bias transistors, thank you, right? They don't exist, so you got to figure it out yourself. So I ended up settling on KSC 2383s to use as the bias transistors. So I kind of put together a couple of those. I used as much of the original wiring. Now this one side had the original wiring, you know, wires with different colors. The other one had all red. But anyway, I try to save what I can, and there's no reason I can't save the wire. So I saved the wire on one side. So now it's time to see if I can adjust the bias first of all. If I can do that, I'm going to feel pretty good that this is going to work. So anyway, I installed the driver cards, and I was able to adjust the bias high and low off 180 milliamp spec that it has for its bias current, and I was able to adjust it up, adjust it down, adjust it on, and it stayed there. I gave it a period of time to warm up, and I felt pretty good. This was going to work. But I did notice, you know, when I was doing this has nothing to do with the bias, but I had about 80 millivolts of DC offset on the right channel. And again, after some troubleshooting, I found out that I had a defective 2SA 798 transistor. This is kind of like a 2-part transistor. These don't exist anymore either. So what I did, I used 2 gain match KSA 992s to replace it. And that seemed to fix that problem. My DC offset went down to near 0, and that was good with that. Oh, the power switch. Remember that way back when? I ended up finding a used power switch from a Spec 4 on eBay. The mounting hardware did not match up. What a shock, right? The Spec 4 didn't quite match up with the BA-5000, but it wasn't that big of a deal to get it mounted, and it works fine, and it looks good. You know, obviously you wouldn't know that that's a Spec 4 Pioneer power switch inside this Sansui BA-5000, and certainly hell of a lot better than no power switch at all. I routed everything in neatly. Gonna have to, you know, I had to untie, you know, many of these tie wraps were cut, and so you gotta, you know, get everything installed back in. I'm gonna do some bench testing, obviously, before you put it back together totally. Gonna spend a few hours on the test bench, testing it out, making sure everything's good. Tested it out fine on the bench. So I reassembled everything. You know, she looks a lot cleaner. She'll never look perfect. She was pretty beat up and had a hard life there for a few years, but there's really no reason that this amp can't be used every day now, and I wouldn't be surprised if in 45 more years the next person's working on it and restoring it for its next 45 years. It wouldn't surprise me. As I said, it'll never be cosmetically perfect, but you know, that's one of the reasons I like vintage audio equipment. You know, this poor thing was abused for decades. Some work on it and thrown in a few bucks. There's this, as I said, there's no reason it can't go on for decades more. So it just wasn't shown much respect for a long time, but now it's ready again. It's ready for everyday service. I don't know that the Sansui engineers really were thinking. If you could talk to one of them, it'd be, I doubt when they were designing this, they were thinking somebody's going to have this in their stereo 45 years later. But you got to really give it to them. They designed a great piece of equipment, and it's built, you know, obviously much better than the equipment is today, and it's really a great sounding unit also. I think we're about done here, so this Sansui BA-5000 power amplifier repair and restoration is complete. It's time for some music. Hooked up my Sansui BA-5000. This is the one you see if you've watched the video ahead of this. This is the one I rebuilt. It's never a disappointment. Obviously extremely powerful, but not only that, from the lowest notes to the highest, there's no disappointments. So you ever get one of those amplifiers that put any kind of music on and it always sounds good? The music's got a lot of tight
heavy bass, that's what you're going to hear. If it doesn't, you're not going to hear it. So it's pretty honest to the music. It's got a nice mid-range, and the top end is very nice, crisp and clear. I hope that you enjoyed my Sansui BA-5000 power amplifier repair and restoration. If you did, I'd appreciate a big thumbs up down below. For you non-subscribers, if you enjoyed this video and you'd like to see more like it, please subscribe. And for my present subscribers, as always, thank you so much. Y'all have a good day.